Welcome back, Year 5. In today's math lesson, we'll be doing some problem solving involving decimals. Now, we're going to be using bar models to help us do this, so we have two learning intentions. The first is to apply strategies for solving problems involving adding and subtracting numbers with up to 3 decimal places. Our second intention is to interpret and use bar models. We're actually going to start with that second intention because it's going to help us with the first one. So I'm going to show you in a moment how to use a bar model to solve addition and subtraction problems. So let's start by looking at some bar models. Now, once you get the hang of them, they're actually quite simple because really what they do is they show a fact family. For example, for A, we see 100 on the top, and along the bottom there's two spaces. One of those spaces is 50, and the other space we don't know. What's important here is that the top bar is the same value as the bottom two bars together. That's why they end up being the same size. So it takes these two bars to be the same as the top bar. So that tells me that 50 plus some other number is supposed to be the same as 100. So how do I work out what the missing number is? Well, chances are we already know it because this is a pretty simple problem. But if the numbers weren't so easy, there's a way for us to work it out. Since it's a fact family, I can say this mama number on top, take away this baby number will give me the other baby. Remember we talked about that in class? So I could simply do 100, my big number, take away one of the smaller numbers, gives me my missing number here, which is 50. And it works the other way around as well. These two baby numbers together give me my top number, my mama number. So 50 plus 50 equals 100. So my question mark in this case is 50. That was my missing number. And I proved it two ways, by doing the addition and also by doing the subtraction. What about this one? Now that we know that the big bar is the mama number and these are the two babies, how do I figure out my missing number here? Well, I can add together my two babies, 75 plus 25. And they'll have the same value as the bottom bar, the mama number, and that's 100. So my missing number is 100. Down here, it's the same thing again. We have two baby numbers and a missing mama number. So we add these two together and it will give us the same value as this bottom bar. 23 plus 25. 5 and 3 makes 8. 2 and 2 makes 4. So our missing number here is 48. All right. Again, what do we have? Two baby numbers on top and the missing mama number, because this bar it's one bar and it's the same length as these two together. So that means that this is the mama number. It's the biggest number. So I added my two babies, 143 plus 325. And what do I get? 5 plus 3 gives me 8. 2 tens plus 4 tens gives me 6 tens. And 3 hundreds plus 100 gives me 400. So my missing mama number, 468. And finally, we have a mama number, one baby number, and a missing baby number. So I know these two baby numbers together should add up to give me 100. So one of my number sentences can say 92 plus the question mark number is going to equal 100. Or I can simply do the subtraction. 100 take away the number I know gives me the other missing number. So 100 minus 92, and what's that going to leave me? What's the difference? 8. And I can prove that with the addition as well. 92 plus 8 equals 100. So my missing number in this case, the question mark, is 8. Now on the left-hand side of your screen, you should see the 5 questions I just worked through. I did the first 5. What I want you to do is the other 5, and then we're going to move on to the textbook. All right, on to the discover portion. There we get some information about astronauts. It says, fact, an astronaut that weighs 76.8 kilograms on Earth weighs only 12.7 kilograms on the moon. And that's true. They're not making this up for our textbook. It's because of the effect of gravity. there's a greater force of gravity on Earth than there is on the moon. Have you ever seen in movies where astronauts kind of like bounce on the moon? It's because there's less gravity. So because of that, they weigh less because there's less force pulling them down to the Earth. Over on the other side, it says life support mass, but it looks like his hand is covering up some information. So I'm thinking we're going to need to find that information later. And underneath it says spacesuit mass, 49.89 kilograms. All right, let's start with 1A. How much more is the weight of the astronaut on Earth than on the moon? All right, well, that's a simple finding the difference question. We're going to need to subtract. And here's why. Let me show you with a bar model. It says that the astronaut weighs 76.8 kilograms on Earth, but he weighs only 12.75 kilograms on the moon. So we can imagine his weight on Earth as the big mama number. I'm going to turn that into a bar. Now, his weight on the moon is one of the baby numbers. It's less, 12.75. To get to the weight on Earth, I would need to add something on to 12.75 to reach over here. So all of this made 76.8 and it reached over here. 12.75 only reaches here, so I got to add on to it. So what's missing? Well, for me to find what's missing, I need to find the difference. So I can do 76.8 take away 12.75, just like we did before with those bar models. Now I notice right away that I've got an empty space up here. What do? That's right, put my placeholder. It doesn't change the value of the number when I put a placeholder after a decimal point. So now I can do 0 take away 5. Wait, no I can't. More on the floor, so I go next door. That becomes a 7. This becomes a 10. 10 take away 5 is 5. 7 take away 7 is 0. 6 take away 2 is 4. 7 take away 1 is 6. And there I have it. This number, 64.05, is the difference between 12.75 and 76.8. So it is my final answer. He weighs 64.05 kilograms more on Earth. Now on to the B question. The mass of the life support is 90.2 kilograms heavier than the spacesuit. What is the total mass of the spacesuit and life support? I am sensing a two-part question. The first thing I'm going to have to do is find the mass of the life support, because remember, his hand is covering that, so I have to work it out. Then when I found it, I need to find the total mass of the life support and the spacesuit. All right, first let's find the mass of the life support. It says it's 90.2 kilograms heavier than the spacesuit. So that's telling me that the mass of the spacesuit, which is 49.89, plus 90.2 is going to give me the mass of the life support. Do you see my bar model emerging? It takes these two numbers to make my mama number down here. So let me stack them and add them up. 49.89, 90.2. And again, empty space, fill it with a 0. So the mass of the life support is 140.09 kilograms. I'm going to label that here because this is not my final answer. Why? They don't ask me what's the mass of the life support. They ask me what is the total mass of the spacesuit and life support. So what do I need to do now? Well, I have the mass of the life support and the mass of the spacesuit is in the book. So all I have to do is add them together to find the total. So here's that life support, and the mass of the spacesuit is 49.89. Notice that I lined them up by the decimal point. 9 and 9, 18, 9, decimal point. There we have it. So the life support plus the spacesuit added up to this, 189.98 kilograms. And that is my final answer. So this was a two-step problem. First, I had to find the mass of the life support. Then I had to add it together to the spacesuit mass to get my final answer for the total. All right, now we're going to move ahead to the think together portion, and we're going to dive straight into question number 2. It says there, how much do the science magazines cost in total? Explain your method. There it shows me 3 magazines. One is £4.99, another is £2.99, and the last one is £5.88. And it shows me also the bar model. And the question mark is at the top, so I know I need to add these values up to find my final answer. Now, there's actually a couple ways I can do this. Notice the prices are all very close to a whole dollar. I have £4.99. That's only 1 cent away from being £5. Then there's £2.99. That's also only 1 cent away from being £3. Then I have £5.88. This is 12 cents away from being £6. But I want to focus on these two. When you go to the store and you see something that costs like $3.99 or $6.99, you usually just round it up to the next whole dollar, don't you? Let's try that here. If we round these up to the next whole dollar, what we'll be doing is adding 1 cent, or 1/100th of a dollar. So what I'm going to do to make this a little bit easier to do mentally, I'm going to pretend that this is £5. And I'm going to pretend that this is £3. And then I'm going to keep this one as £5.88. Now when I go to add them up, I've got a lot of zeros, which makes life so much easier. 0 plus 0 plus 8, 8. 0 plus 0 plus 8, 8. 5 plus 3 plus 5. Well, I like to do the 2 5s and make a 10, and then plus 3 is 13. £13.88. But remember, we added in 2 cents. 1 cent, 2 cents. To make these nice round numbers. So to get my actual answer, all I have to do now is take away 2 cents. Well, taking away 2 cents is going to change that 8. It's going to knock it down by 2. So my final answer is actually going to be £13.86. Now, I did this all on paper, but the truth is I could have done this in my head by using this strategy. Because I just think 5 plus 3 is 8. 8 plus 5 is 13, and then I have my 88 cents. So £13.88, take off my 2 cents, and then I end up with 86 pence instead. If you don't like this strategy, perhaps you don't like compensating, which is what this is, you could just stack them. So you could do, make sure I'm skipping a line, $4.99 plus $2.99 plus $5.88. But what's going to happen here is you're going to do quite a bit of regrouping. 9 plus 9 is 18. If I add another 8, I get 26. So I put my 6, carry my 2. 26. 9 plus 9, 18. Plus 2 is 20. Plus 8 is 28. Put my 8, carry my 2. 28. Come on, focus. 2 plus 4 is 6. Plus 2 is 8. Plus 5 is 13. £13.86. The exact same answer, but it was a lot more regrouping. This method, even though when I wrote it out it looks like more work, it's much easier to do in my head. So this here, adding on that 1 cent, is compensating. Now, before we move on to the independent work for today, I would like for you to try today's challenge from the textbook. It says there, astronauts bring 3 rocks back from the moon. Rock A, rock B, which weighs 12 kilograms, and rock C. The mass of rock A is 3.6 kilograms less than rock B. The mass of rock C is 4.75 kilograms greater than rock B. The first part of the question asks you to work out the total mass of the 3 rocks. Then it says for B, how much more does rock C weigh than rock A? Now what makes this a challenge is that there's quite a few steps. First you have to work out how much rock A weighs, then you have to work out how much rock C weighs, and then to solve A, you have to add up the weight of all 3 rocks to find the total. Finally, for B, to find out how much more rock C weighs than A, you have to find the difference. So I want you to go ahead and try that. And now for your independent work. Question 1 on the first page just involves using some bar models to do addition and subtraction. It's pretty straightforward. Questions 2 and 3 require you to use the information that you're given to solve the problem. So you might need to add or subtract based on what the problem says. You need to determine, are you finding a total or are you calculating a difference? Now question 4 isn't actually that hard. It's just going to require a little bit of trial and error. You need to pick 2 of those numbers and make sure they add up to 1.2, but when you subtract them, they should equal 0.78. So take your time, play around with that one. Or if you have a very good eye, you might notice without having to do any calculations on paper, the relationships between those numbers. Question 5 isn't particularly hard either, but it does require you to understand place value. Notice the first number is 100. All the other numbers that you're taking away, you need to make sure that you line them up by the decimal point. If you don't, you're going to get the wrong answer. So make sure you use your placeholders for that question. When you write 100, you might want to put 100.00 if that makes it easier. And finally, the challenge question, please pay close attention to what it says. It says she has 20 pounds, she spends 3 pounds 20 pence, and then another item she buys costs 5 pounds 90 pence more than that first item. And then it asks you not for how much she spent altogether, but for how much change she is going to get back from the 20 pounds. So what makes this question a challenge is that it has quite a few steps. So make sure you read that question through carefully and understand it. Take it one step at a time. And as always, you need to do your reflection, and when you're done, take a picture of your work and send it to me. All right, year 5, stay safe, and I'll see you soon.